Good morning, everyone. My name is Monica Ospina. Thank you for joining our live session from our air monitoring site. We are today in the Banu-NCORE site dedicated to Daniela Banu. She was an air quality champion. So follow me. So today we're going to go live with Dr. Sybil, and he's going to walk us through the air monitoring site. So here you go, Dr. Sybil.
Hey everybody, this is the NCORE Banu site that we have in Broward County, named after Daniela Banu. Was one of our outstanding air quality program enthusiasts here. I wasn't here when she was here with Broward County, but from what I heard, she was an amazing woman. So that's the reason why this building was named after her. So if you can step inside here, first thing you'll notice is our analyzers, and honestly, these things cost about maybe $10, $15, $20,000 per pop. So this is probably like a car sitting on this rack as far as like its worth. This is our ozone analyzer, this is our carbon monoxide analyzer, and this is our sulfur dioxide analyzer, monitoring our criteria air pollutants that we're required to keep track of with clean air. This is the computer that we use to pretty much look at all of our data. This is actually the live ozone concentration right now at the NCORE monitoring site, getting up into 33 parts per billion. And this is our nitrogen oxide analyzer, NOI specifically. It monitors reactive species of nitrogen. And I'll probably take you guys outside and have a look at it. It's the big tower, 10-meter tower with a big silver box on top of it. So yeah, this is the NCORE site. We also have PM monitoring on the platform in the back, which we can go to right now if you want to. Or, yeah, all right, so sounds good.
Okay, so we have a couple of questions.
All right.
Tell us more about your background.
My background is actually starts locally. I am an alumni of South Plantation High School, their environmental sciences magnet program, and then I went to Tallahassee and graduated from Florida State University with a bachelor's in meteorology, and then went across the tracks and enrolled in FAMU and their environmental sciences program, and graduated with a doctorate in environmental sciences.
So why do you do what you do?
It's a passion, and it's just been a passion to understand the sciences ever since I was a kid. I actually wanted to be a meteorologist ever since I was like 5. I think that was around the same time Hurricane Andrew hit, and it just sparked a natural curiosity for me. But then as I got older, I started to realize that I have a passion for education as well, and in order to educate people about the sciences, I have to dive into the sciences myself.
So how exactly did you get into air monitoring? Like, what's the story behind it?
So air monitoring actually started for me in grad school with my dissertation program, and my dissertation is on atmospheric ammonia deposition and how it relates to the dead zone in the Gulf of Mexico. And what we ended up doing is we traveled up to Illinois and monitored ammonia during the growing season, the corn growing season up there, with Dr. Latoya Miles. Shout out to her. She's one of my NOAA mentors, so she played a big part in my professional development. But yeah, that's where the air monitoring started.
So what exactly is air monitoring for the people at home?
It is basically monitoring a select group of chemical species that have been identified to impact the air adversely, and because it impacts the health of the population, the Environmental Protection Agency identified these criteria air pollutants that should be monitored. And yeah, we use those instruments that you saw inside to put together an air quality index of what the atmosphere is like, basically a health report, and disseminate that to the public.
And so why is it important to monitor our air? I know some people have asthma, some people have allergies. Why exactly do we monitor our air?
Exactly. There's some sensitive people in the population that can't exactly handle air that has too high of ozone or too high of particulate matter, people with underlying respiratory issues, or the elderly. It's important to monitor. Yeah, we have wasps out here too, so they're not exactly as friendly as I am. But yeah, it's important to monitor the air quality for that specific portion of the population because it matters to them. It affects their health. But in general as well, you know, it doesn't take a sensitive person or underlying respiratory issues to impact your
Okay, so I think now we can go check out the back
Yeah,
and
sure.
show everyone the monitors. So basically we can show you what you do on a daily basis.
Pardon the flooded grass. It's been raining, as you guys know, for it feels like what, 4 or 5 days.
Mm-hmm.
So unfortunately, we get some standing water out here, which equals frogs and mosquitoes. But you know, such is life. This is part of the job. So these are our particulate monitors, monitoring particulate matter. And this is our manual particulate matter monitor. Basically, if you come take a look inside here, there's filters in here that we install on pretty much like a weekly basis. And once it's running, it pulls air through these filters, and then they get sent off through to our lab in Tallahassee, and they pretty much give us an assessment of how good or bad our particulate matter, I should say, is for that running period.
So what are the two most common sources of particulate matter here in Broward County?
Whenever the Everglades is on fire, I know you guys smell it. It's pretty bad. That tends to be the cause for the predominant cause for particulate matter. But also there's instances where Saharan dust can cross the Atlantic and impact our area and cause that raspiness, you know, things of that nature, and combustion as well. But we really don't see that problem too often, just because we get plenty of sea breeze effect. We're not really getting stagnant air in our portion of Florida, just because, you know, we generally get a sea breeze going daily. This is our particulate matter, that particulate monitor that runs continuously. As you hear, that guy is running right now and giving us live data. So the monitor that I just showed off runs once every 3 days. This one is running 24/7, giving us particulate matter data. And the stuff that you see right there, that's a temperature probe. It's important to keep track of the temperature when you're doing this type of analysis. And that guy up top there is our inlet monitor, because we're only looking for particulate matter that's between 10 microns and 2.5 microns. Anything bigger than that, we're not really concerned with. So that outlet filters out the stuff that we're not really concerned with. By the way, that tower right there, that tall tower, was the NOI analyzer, the part of it that you don't see in the building. And the inlet's all the way up top there. It's that little tube that's hanging down.
So how many sites do we have throughout Broward County?
We have one in Pompano Beach. This is our Davie site. We have one by the beach, and we have one over in Vista View. We also have a site that's not as equipped with analyzers as far as ozone and everything like that, but we does monitor particulate matter in Coconut Creek. It's a little platform if you guys have seen it up there.
Okay.
And Daryl, I have a question. What are those little things that are like glistening?
Oh, okay. Little metallic fuzz balls.
Yes.
So, as you could imagine, when you have stuff that's just sticking out in the sky in Florida, that is prone to lightning strikes. So what we do is we use that to try to diffuse the charge that gets generated on it and hope that no type of positive leaders start to reach up into the sky and attract, the negative lightning bolt that comes and connects and creates your lightning. So yeah, that helps diffuse the charge a little bit. Now that doesn't mean that it's fail-proof. We've had issues, especially with that monitor right there, where it gets hit by lightning, or it gets, I guess, a static charge effect. Lightning hits in close proximity to it, and it happens to, unfortunately, bring the instrument offline.
Okay, and so so if the monitors go offline, what happens? Like, why is that a bad thing?
It's a bad thing because we are tasked with keeping these monitors online 24/7, 365 to the best of our ability. And anytime an instrument is broken, that results in downtime and data that's not being captured. So our job is specifically to get as much data as possible.
So why are we located on a large field instead of like a controlled area?
So that's actually a site requirement for EPA. They want to make sure that all these measurements that we're getting isn't being affected by biases nearby, whether it be, a smokestack. This happens to be like a residential community, so we're not going to see any things of that nature. But that's pretty much what EPA is trying to ensure against, that the data that we're pulling and sending to them and the Florida Department of Environmental Protection isn't biased in any way.
And I have a question. So, like, if we look here, what are these lines? What is this?
So those are exhausts. So the analyzers that you saw inside, they have to vent out the air that they're pulling in. And you can probably hear it too. All that air that gets pulled in to the analyzer naturally has to come out, and it's being vented out through these exhaust lines. The other lines are network connectivity antennas.
Are the black ones?
Yeah,
Okay.
the black ones. Thank you, Broward ETS. They've come out here on numerous occasions because Lord knows we have enough internet connectivity problems here. It's important to maintain an internet connection out here because that's how we stream data out.
And Daryl, one question. So you're saying that these lines, these is where like the air comes out of. But where does the air go in so that the equipment, the analyzers actually capture that air?
So if you look straight up, there's those white funnels. I think this one is ozone, this one is sulfur dioxide, and this one is carbon monoxide. And the reason why we have funnels at the tip of the sampling line is to shield it from rain, because we're not trying to pull any type of moisture into those lines. If there's any moisture that gets into those lines, it's going to impact the data. You're going to see all types of weird, erratic readings, and that's just, it's not good. It's not a good situation. FDEP yells at us, EPA yells at us. We're trying to keep them happy.
We have more viewers now. Do you want to go back inside and show a couple more of the equipment off?
This is your ozone primary standard. Now this isn't reading ambient air. What this analyzer's job is to send a known concentration of gas to our ozone analyzer. And what it does is it allows us to evaluate how accurate our analyzer is versus the primary standard. When we're calibrating our ozone analyzer, we send specific concentrations from our primary standard to our analyzer, and then that's what we use to give it these set calibrations, and that's what it uses to pretty much analyze the gradient using some type of formula that's way too complicated to explain right now.
So what are some things people at home can do to practice citizen science and monitor their air quality from their backyard?
There are some brands out there that we're looking into as part of what we're trying to do with our citizen science program. and see how well they match up with the actual expensive analyzers that we have here. So what we hope to do with our citizen science project in the future is to identify just some of these lesser cost equipment that we can dole out in a larger fashion than these, because obviously we can't give a bunch of these out to our citizens because we can bankrupt. But those inexpensive solutions that's going to good data, that's what we're looking for. That's what a large part of the scientific community that are interested in citizen science projects are looking for.
Okay, so we have one question. This is from Bishop Palmer. He says, in terms of gases, what gases are sampled and how do you account for the introduction of something new in the environment? For instance, methane.
And sorry, Bishop, can you tell us if you can hear us? Because there's a lot of equipment in here. So I just want to make sure that the noise isn't so loud.
All right, maybe out here's better.
So what we're monitoring is our criteria pollutants that are identified in the Clean Air Act. So that's carbon monoxide, sulfur dioxide, your reactive species of nitrogen, so your nitrogen oxides, ozone, particulate matter, and the one criteria air pollutant that we don't monitor because frankly it's been outdated is lead. Lead was written into the original Clean Air Act, but as we shifted away from leaded gas to unleaded, it's no longer a problem. So consequently, we no longer monitor for it. But as far as like the other things like air toxins, this machine here, which I don't run, so I can't really explain too much on. This is our air toxins analyzer, and what they'll do is they'll connect a big silver can onto this machine and just pull in air. And what they do is they take that back to the lab and they sample for a variety of different species, so that kind of covers things outside of our criteria air pollutants.
Bishop had a follow-up question. He said, or is a sample size static? Is a sample size static?
So by static, I guess it means are we pulling a constant stream of air? Yes, we are. I don't know how well it can see the screen, but this is our flows through the two cells that are in our ozone analyzer, and that's pretty much our constant right here. It's giving us 0.669 liters per minute. Cell B is coming through at 0.675, and it varies, but that's pretty much the constant that we hover around, that is pulling 24/7.
All right. So if anyone has any further questions, please put them on Facebook right now.
The whole reason why we do all this though, especially the citizen science portion of it, is because I think there's a great quote that I threw into my dissertation. I'm trying to remember. It's by Baba Diem. I think it goes, we will love, we will conserve what we love, we will love what we understand, and we understand what we learn. So I think that's just so profound to what the sciences are just trying to do in general, whether it be air monitoring, meteorology, even in our medical field as we're actively fighting the coronavirus right now. All those frontline workers, what they're trying to do right now is just add more to the knowledge base and database so that our scientists and our decision makers can make more informed decisions. And that goes just pretty much to everything that science is trying to do.
Well, Dr. Sybil, thank you so much for giving us some of your time today. We appreciate you and we hope you enjoyed it. Thank you so much.
Guys, take care. Be safe.